welcome to another live stream, guys. Welcome. So today we're gonna have a look at magnetism, just like it says in the title. So we'll also be having a look at electricity. So we'll have a look at like current, resistance. Do some examples. Now the notes is down in the description. I'm using Save My Exams. In this topic, I think Save My Exams has the best notes. Literally the best diagrams, best notes, and everything you need to know about magnetism, magnetic materials, electromagnets, motor effects. Everything is going to be covered in this live stream. I'm going to try my best to wrap up the entire topic 5. Now some people say this is topic 4, like Save My Exams, but I believe IGCSE is calling it topic 5. So whatever you want to call it, either topic 4, topic 5, the main topic or the agenda for this live stream is to learn everything related to magnetism and electricity. So we're going to have a look at diagrams, we're going to have a look at definitions, and then maybe in the future we will look at some past paper questions. Okay, sorry about that, but we just had a small sort of issue with the live stream, but we are, I think, back. Okay, so yeah, what I was basically explaining was just magnetism and electromagnetism, just a general effect. So what we're going to have a look at, first of all, magnetism, okay, give some quick definitions. Then, of course, we're going to have a look at some electromagnets. We're going to then, of course, have a look at electricity and do some examples and some diagrams. So, without further ado, let's just begin. So, the first thing you can see right here is talking about magnetic field. Now, I'm going to be highlighting the key importance. So, magnetic field. So, what are magnetic fields? Basically, a magnetic field is the space around a magnet. So, you can see this diagram right here. So, this is a sort of magnet, and we all know magnets. So, right here is the North Pole, and here's the South Pole. Okay. So what these lines that are running from north to south, we call them a magnetic field. Okay, we call them a magnetic field. So they run out of the north and enter into the south. Okay, and later on we'll get to know that if they're closer, they're more stronger and stuff like that. Okay, so we'll have a look at that, and also we need to know some rules that must be obeyed when drawing the magnetic field. So keyword right here, magnetic fields. Okay, so magnetic fields, what is a magnetic field? It is the space around a magnet. Okay, it is the space around a magnet. Now magnetic field lines are a very useful way to help us to picture that field, okay, and its strength and its direction. Okay, so its strength and its direction. So basically magnetic field lines are like a sort of way to help us to picture a field, its strength and its direction. Okay, so you can see right here we have north, we have south. So we have north and we have south, and then so we have just a few magnetic field lines running from north to south. Okay, and then he simply says that the magnetic field around a bar magnet. So this is a bar magnet. Later on we'll have a look at other types of stuff like solenoid, and we'll have a look at the magnetic field on solenoid. Now, magnetic field lines obey a couple of rules, um, and they always go from north to south. Okay, so they always come from the north and then head off to the south. Okay, so that's something you need to keep in mind. Uh, and also, they never ever cross the field line. So whenever you're drawing, these magnetic field lines, you always need to know that they will never cross each other. Okay, so they will never cross each other. So that's two rules that you must know with looking at a bar magnet. Okay, now we have some diagrams right here which says that two magnets, okay, this is like sort of the law of attraction between magnets, and it's quite simple, and it says that when two magnets, okay, are held close together, there will be a force, okay, there will be a force between the magnets. Okay, so for example, we have North Pole and South Pole, and we all know this, okay? This is like primary physics. We know that when unlike poles are brought together, they attract. Okay, so in this case right here, you can see it's saying that the opposites will attract. The opposites will attract, and the like poles will repel. So if it's north and north, they will repel. Okay, so in this we're looking at when there are two bar magnets. So when there's bar magnet 1, bar magnet 2. When there are two magnets, and when they're brought together, we have a force that exerts. Okay, when they're opposite, they attract, meaning they come together. But when they are unlike, but when they're like poles, they will repel. Okay, next up we have magnetic material. Okay, so these two diagrams right here were they're basically both bar magnets. But what happens when we put a magnetic material together? Now, magnetic materials aren't magnets. Okay, so first of all, you need to know these magnetic materials aren't magnets. Okay, but these magnetic materials are attracted to either pole. So if you bring it to north, it's going to be attracted. If you bring it to south, it's still going to be attracted. But we do not call them as bar magnets. Okay, these are just called magnetic materials, and later on in this live stream we will give you some examples of different types of magnetic materials. Now, magnetic materials are not magnets. Okay, first of all, you need to keep that in mind. They are not magnets, but will always be attracted to a magnet. Okay, regardless, with any pole, it will still be attracted. Now, a magnet can only repel another magnet. Okay, so a magnet is the only way I can repel another magnet. Okay, and I can repel by the like poles. Okay, so let's move on, and now we are having a look at some extended ones. Okay, so extended. So the first thing you need to know is plotting a magnetic field. Now there's a very common experiment that you will come on. Okay, and many questions in the IGCSE examinations will ask you to describe a method of the plotting the magnetic field. Okay, so basically what this means is an experiment to show the magnetic field line. Okay, and there are two methods that you need to know for this IGCSE exam. The first one, and a very common one, is using iron filings. Okay, iron filings are basically those small pieces. Okay, like small pieces of iron filings. They're very tiny and like they're powdery. Okay, so that's how we know that those are iron filings. So now, how does the experiment work? Okay, first of all, you take a bar magnet. Okay, for example, this is my bar magnet. It's not really good. Okay, this is my bar magnet. I'm going to take a piece of paper and cover it. Okay, I'm going to take a piece of paper and cover it, and then I'm going to sprinkle my iron filings. Once when I sprinkle it, there will be basically something that will be around the magnet. Okay, and that thing that's formed right here, as you can see in this diagram right here, is the magnetic field. So this magnetic field right here, as you guys can see, that is the magnetic field around a bar magnet. By just sprinkling some iron filings, we can see that. Okay, now iron filings can be used to plot a magnetic field. Okay, so that's a simple experiment that you can use. Now, here is the process. Okay, first of all, place the magnet on top of the piece of paper. Okay, you draw a dot at one of the end of the magnet. Okay, and that's the one's near the corner. Okay, and then place a plotting compass next to the dot. Okay, so that one end of the needle of the compass point towards the dot. Okay, Then use a pencil to draw a new dot at the other side of the compass needle. Now this is a quite hard experiment to sort of show like now online, but basically the main thing is that when you put the compass around, okay, the North Pole, wherever it's not facing is the North Pole. I mean, I don't know if you can see in this diagram right here. Okay, so this right here is the compass, and you can see the opposite, okay, where it's red, okay, the opposite is the North Pole, okay, and this side is the South Pole, okay, and you can see it's in an arrangement like this. That's how you observe it. So by putting points around the bar magnet, you can find the magnetic field around the bar magnet. But I prefer the first experiment because it's quite very easy. You simply have to say put a paper on top of the bar magnet, sprinkle some iron filings, maybe shake the paper a bit so that they can get the position, and then observe the magnetic field around the bar magnet. Okay, so that's quite easy and quite simple. Okay, and we're now going to move on to the next topics. That was a quick topic talking about just magnetism. Now we have a look at magnetic materials. Okay, so magnetic materials are very, very important too. Okay, so magnetic materials. Okay, so we're having a look at some magnetic materials. First of all, a magnetic material is a material that experiences a force when placed in a magnetic field. So you need to know all these terms, okay, all these definitions. Okay, when it asks you what is a magnetic material, you simply say this is a material that experiences a force when placed in a magnetic field. Okay, so it is simply something that experiences a force when you place it in a magnetic field. Okay, and we know what magnetic fields are. This is the space around a bar magnet. Now, although all magnetic materials are metallic, not all metals are magnetic. Okay, it's a very good statement there. All magnetic materials are metallic. Okay, so in the materials that we're seeing right now, all these magnetic materials are metallic, but not all metals are magnetic. Okay, and now there's a simple four materials that you must know. First of all, iron, steel, nickel, and cobalt. Okay, so these are the main ones that you need to know. Okay, so these ones right here you must know: iron, steel, nickel, and cobalt. Iron, steel, nickel, and cobalt. You can make an acronym. You can get a way to remember this, but you need to know this: iron, steel, nickel, and cobalt. Okay, so now we have just a quick experiment here. So we have just some magnetic materials like a paper pin getting attracted, some pins and a coin and all of that getting attracted because they're made out of these four magnetic materials. Now we have different types of materials. Okay, so we have hard materials and we have soft materials. Okay, let me tell you what this means. First of all, I've talked about this in a previous live stream, but let me emphasize on this more. Okay, so first of all, hard materials. Hard materials, an example would be steel. Okay, now hard materials are simply hard to magnetize. Okay, from its name, hard materials are simply hard to magnetize, and also they are hard to demagnetize. Okay, and therefore that means that they're sort of hard, they don't lose their magnetism over time. But as you can predict, for soft materials, they're easy to magnetize and they can also easily lose their magnetism. After that, we have something called permanent magnets and electromagnets. Okay, now electromagnets is a whole big topic in physics that we'll have a look at. But simply what this means is a permanent magnet is made out of magnetically hard materials. Okay, so permanent magnets are made of hard materials while electromagnets are made of soft materials. Okay, this means that electromagnets, they can easily gain magnetism and easily lose magnetism. Okay, but we'll have a look at electromagnets in a later stage. Okay, so let's move on to induced magnetism. Okay, now induced magnetism is basically ways I can make a magnetic material magnetize, or make a material, sort of magnetize temporarily or, forever. Okay, so we call this topic induced magnetism. When a magnetic material is placed in a magnetic field, that material will become magnetized. Okay, So let's give it some examples. So first of all, one end of a material will become a north pole and the other end will become a south pole. Now later on, just like the previous slide, the previous topic when we were having a look at magnetism, I said that a magnetic material will be attracted even if it's a south or it's a north. Okay, so it doesn't matter. So for example, if I put a north, okay, so this is a bar magnet right here, this is a bar magnet, and you can see it's north here. So what happens is this magnetic material will become a south pole. Okay, hopefully you're understanding this. Okay, so that is how it is. Now when a magnet is held close to a magnetic material, the material temporarily becomes magnetized. So this is a very good statement that you can also write down on how magnetic materials work. Now this process is called magnetic induction. Okay, magnetic induction is simply when a magnetic material becomes magnetized temporarily. Okay, so when a material is removed from the magnetic field, it will start to lose magnetism. Okay, just like a bar magnet. So when I, keep it further away, the magnetism will reduce. Okay, so that was a quick topic just talking about some magnetic materials. And the main thing you need to know in this topic is that the four magnetic materials, you need to know soft magnets and hard magnets. Okay, let's move on to the next one and let's talk about magnets and electromagnets. And remember, electromagnets are made from soft materials as we mentioned before. Now, magnets and electromagnets. Okay, so first of all, you need to know creating and destroying magnets. Okay, so magnets are usually made from hard magnet materials. Okay, so magnets are made from hard materials. But later on, we'll get to know that electromagnets are made from soft materials, and there's several ways in which a magnet can be created. So now this is the way to magnetize a material. The first method that you need to know, and you need to know these methods, and the first method you need to know is called stroking with the magnet. Okay, so here I have a magnetic material. Okay, so maybe I just have, for example, steel. Okay, and remember the four magnetic materials. Okay, let me just uh, get you to revisit that. So the four magnetic materials, remember, is iron, steel, nickel, and cobalt. So from those, any of them, I can perform this sort of experiment. So the first thing, if maybe I bring steel right here, okay, and I have a magnet, and if I keep on stroking this, stroking, is going this, it's stroking like the way you rub something. The same thing we say stroking. So when you stroke this magnetic material, for example, steel, okay, when you stroke it with a magnet, then this will become a magnet. Okay, this will become a magnet, and it says right here a magnetic material can be magnetized it with one end of another magnet. Okay, so that's a quite simple topic right there. And it says using a direct current in a coil, you can also magnetize. Okay, so when you put DC, we'll also later on get to know about the motor effect, using DC motors, AC motors. We'll have a look at all of that later on, but right now what it's kind of not in the topic right now, but basically for now we're saying that using DC in a coil, okay, and when you wrap it around a magnetic material, it will become magnetized. So when you place a magnetic material in a coil and then pass direct current is simply just electricity through the coil, it will magnetize it. So we have two ways that we have looked at now, stroking method, and then we have looked at the magnetizing, the way when you put a direct current through it. Next up, we say hitting with a hammer. Okay, so hitting with a hammer. Okay, then it just comes from its name. If a material is placed in a magnetic field and then hit with the hammer, the material will also be magnetized. Okay, now hitting the material placed into the magnetic field with a hammer can lead to the material becoming magnetized. Okay, that is the methods of magnetization. Okay, what about the methods of demagnetization? So first of all, you need to know that magnets can be demagnetized by using the following methods. Number one, if you hit the material with a hammer. Okay, so we also got to know that if you hammer, you can get magnetized. Okay, but that is only when it is in the magnetic field. When it's not in the magnetic field and you hammer it, then it will become demagnetized. Next up, if we heat the material. When we heat the material and then let it cool, it will get demagnetized. And finally, when you place the material in a coil containing the alternate current. Okay, so the previous one was direct current, DC. This one is AC, and then slowly withdraw the material, uh, and you will get your magnet to be demagnetized. Okay, next up we move on to electromagnets. Okay, electromagnets. What are electromagnets? Now electromagnets are simply when a current is passed through, okay, when a current is passed through a long coil, a current creates the magnetic field around the coil similar to the bar magnet. Okay, and here I was telling you, like in the first topic about the solenoid, here's where we use it. Okay, so the solenoid, as you guys can see in the center right here, and when we pass DC around it, it will gain a magnetic field around it, just like the bar magnet. Okay, so quite simple. Okay, and it says that the magnetic field around a solenoid is identical to the magnetic field of a bar magnet. Okay, so it has the same sort of features. Later on, we'll also, sort of find out if this is north, this is south. We'll have a look at all of that, Fleming's left-hand rule, right-hand rule, and everything like that. Next, placing a soft magnet material such as iron inside the coil would make the field much stronger. So this is the ways to make, the effect, or make the magnetism, or make the magnetic field more stronger. The first one is that if we use a soft iron core in between, okay, the coil, then it will make the field much stronger and the coil will become an electromagnet. Okay, so here it is. Electromagnets have an advantage over ordinary magnets as they can be turned on and off, and the magnetic field strength can be changed. Okay, so that is the reason why we have electromagnets. So we can switch on the magnetic field, switch off the magnetic field. And the strength of an electromagnet's magnetic field may be increased by the following: increasing the current in the coil and adding more turns in the coil. So if I increase the current, and we know by increasing the current, you see if you have the DC right here, if I just increase the current, then my magnetism will be, or my magnetic field will be increased. And if I do more coils, okay, the more these coils, so these are the coils right here, if I do more coils, then we say that it will become more, the magnetic field will become sort of more powerful, or can be increased. Okay, we move on to the next topic now. Okay, we move on to the next topic, and this next topic is finally now on the electrical quantities. So now this is a whole big topic, talking about resistance, current, and everything related to that. And then after that, we'll have a look at electric circuits, digital electronics, dangers of electricity, and then electromagnetic effect. Okay, so positive and negative charges. Okay, first of all, we need to know that objects can be given one of two types of electric charge. Okay, so we can give it a positive or a negative charge. When two charged objects are brought close together, there will be a force exerted. Okay, we say right here that like charges repel and opposite charges attract. Okay, remember that. Like charges repel, opposite charges attract, just like the magnetism law. Okay, so how do you measure charge? Measuring charge is simply in coulombs, and charge is the rate of flow of current. Okay, sorry about that. Anyway, when we are measuring charge, electric charge is measured in the units called coulombs. Okay, so coulombs, and I basically mentioned what charge is. Charge is simply the rate of flow of current. Okay, we move on, and now we say that demonstrating the electric charge. In your exam, you will be expected to be able to explain how to give an insulating materials a charge, and then also describe how to demonstrate the charging of materials in this. Now here's the method that you need to know. First of all, Method: suspend one of the insulating materials using a cradle and length of the string so the material can rotate freely. Then rub one end of the material using a cloth in order to give it a charge. And then finally, take the second piece of insulating material and charge that by rubbing the cloth, and so on and so forth. Now, that's gonna wrap up with today's live stream. I just had to introduce, a bit of electric charge, but that was simply another good introduction of magnetism. And then in the future, we will have a look at more. Now, in the future, I will have a longer live stream, covering the entire topic. So hopefully you will enjoy, that type of topic. So hopefully you enjoyed this quick video talking about, the simple phenomena of magnetism. And I will see you in the next video. So see you and goodbye.